All right, folks, today we're going to look at the volume of spheres. Our central question is, how can I find the volume of a sphere? You might be very used to seeing a sphere as a ball would suffice as a sphere, but not every single type would in sports. So let's define what a sphere is mathematically. And it is a set of all points in space that are a given distance from a given point. I'll show you what that means here in a second. And then we also have a hemisphere. And this is just a sphere cut in half by a circle. So you might be saying, oh, I've heard hemisphere before. They talk about that on Earth, so I guess Earth is a sphere. It's really not. It's not a perfect sphere. It's a little bit more oblong in shape. I'm not sure about the other planets in the solar system. I haven't really studied up on them too much over the years in terms of how it relates to this vocabulary. But people use hemispheres just to kind of describe our certain halves, top half, bottom half, left and right side, or north-south hemisphere, east-west hemisphere, depending on how you're going to cut it. All right, so this is what a sphere is going to look like. What I do is I draw mine up. I drew this guy here, like a smiley face, and then I do like a dotted frown on top, and then I just try to make it like a little curved part here and a curved part here, and that turned out terrible. That's not good. Let me try another one. They both stink. I guess I'm not very good at that. But that set of all points in space that are a given distance from a point, so like exactly middle inside the sphere. So like think about it inside of a tennis ball. Exact middle inside of it. All right, it's the same distance from that exact middle to any part of the outer part of the sphere or that ball, for example. Okay, so maybe it's on the exact middle part where, I guess, if you're going to do a hemisphere where it makes that little circle, looks like it cuts through it, but it can go to any part at any angle. It's going to be the exact same distance. Okay, so that's our kind of idea. Our formula, it's a little bit goofy. Volume equals 4/3 times pi times radius cubed. So totally different than what we've been used to. And there's no real height that we're working with. I guess the height of a sphere would be essentially just the radius doubled, because that would be the height of it. So we're only really looking for the radius here. Okay, so if I give you an example. Example 1, we have a hemisphere, or we have a sphere, sorry, and the radius equals 5 centimeters. I'm not going to dare draw it in this time. Okay, so what we're going to do is we are going to go volume equals 4/3 times pi times 5 cubed. All right, so I can easily go 5 cubed here and give myself 125. 4/3, we'll just leave it as that fraction. Obviously, pi is going to stay in there as well. So when I'm looking at this 4/3 and this 125, really what I'm doing is I'm going 4 times 125, I'm dividing it by 3. Sometimes it works out really, really well and I get a nice easy number. Most of the times it doesn't though. Okay, this number that I get when I cube the radius, it has to be divisible by 3 for it to work out really, really nice. All right, so this one doesn't. 125 divided by 3 doesn't work. Obviously, 4 divided by 3 is going to give me an ugly decimal. So I'm going 4 times 125, which is 500. And then 500 divided by 3 gives me our solution, in terms of pi. So 166.6 repeating pi centimeters cubed. All right, that's what we're doing. Example 2. Our diameter equals 22 meters. I don't know what this is, but it's a big sphere. Maybe it's like an asteroid. Perfect sphere hitting the Earth. I've seen the movie Armageddon before. All right. So we're just going to cut that in half, plug it into our radius here. So 4/3 times pi times 11 cubed. Which, when we multiply all those through, it's going to be volume equals 4/3 times pi times 1,331. 4 times 1,331 divided by 3 gives me a whole large number in terms of pi. 1,774.6 repeating pi meters cubed. All right. Last example 3. It's not that bad. But this time it's a hemisphere. We'll say our distance from here to there is 4 meters. Okay? Now, let's think about this in terms of logic. If volume equals 4/3 times pi times 4 cubed for finding the volume of a sphere, for a hemisphere, I just got to cut that in half at the end. So if I want to multiply by half at the beginning, you can, or you can just take your answer at the end and just divide it by 2. It doesn't really matter. I just kind of like divide it by 2, personally. So I'm going to go 4 to the third power, and that's going to give me 4/3 times pi times 64 divided by 2. And when I multiply all this out, still going to solve in terms of pi. So 64 times 4 divided by 3, and then divided by 2 at the end. That's going to give me 42.6 repeating pi meters cubed. All right, that's all I got. Let me know if you have any questions.